Touch the leg, and greetings to all my dear Tibetan students. I hope you're doing great and keeping up the pace with your studies. Well, I'm here to post lesson number 5 and lesson number 6. Contrary to the earlier video duration of 1 hour, since the last week and henceforth, we'll be keeping the video duration to, let's say, max 30 minutes as per the directives from the SherigVideo. Hence, there were 2 parts in the earlier video and there will be 2 parts this week as well. Well, for today's session, I'll be discussing the subtopic of the chapter file handling, namely handling of binary files. So till date, we have been dealing with operations based on text file, but henceforth we'll be switching over to the second kind of file, and that is binary file. I did tell you the simple differentiation between the two, but since today will be totally into the concept of binary file, let's have a quick recall of the differentiation between the two, the text file and the binary file. Text file, like I said, will support the English alphabetical characters, the symbols, the signs and the digits. The characters generally you find on the top of the keyboard. So the text file will support a character encoding system by the name of ASCII code. I hope you remember when you were in class 11 something about ASCII character encoding system. It uses 7 bits, and then when you use the formula of 2 raised to 7, it gives us the value of 128. So 128 are the numbers which are enough to represent the English language related characters. So whenever you perform operation through the text file mode, you will have no problem representing the characters which are supported by ASCII character system, ASCII encoding character system. What happens when you use binary file is, let's say if you have to deal with some complicated characters, the characters which are beyond the scope of the ASCII character sets, that's when we have to use the binary file. So in binary file, the characters will be stored in the form of binary format, the same format which is used to store the files in the memory, the same format which is used internally in the computer operation. So the obvious difference between the two is when it comes to accessing the data from the file, from the text file or from the binary file, the first difference lies in the speed. The text file based operation will be little slower. The reason is there is this element of translation which is required between the binary and the characters which are represented using ASCII code. But when you use binary file, there is no translation or conversion required, hence the access speed will be far greater. If I give you some example of binary files, there are plenty. MP3 file, MP4 file, PDF, the docx, the files which are generally associated with certain specific program, those files are generally stored in the format of binary file. If you want to listen to MP3 music, we need the music player. It could be Windows Media Player. It cannot be opened in other softwares, other unlike softwares. Okay, so likewise you have the JPG file which could be opened using certain number of softwares which will support the display of the graphics. So likewise The difference between the two is the text file could be opened in any of the text editor, and which is directly understandable by human. That's another difference between the two. The text files could be read by us. It is in human readable form. But when you try to open the JPEG, the JPG file, the image file, the music, the video files, if you try to open it and look try to understand a bit of it, you will not be able to understand anything. It's all scrambled. It all appears in the form of garbage or scrambled, strange and weird looking characters. But they could be translated or they could be understood by their respective softwares. The JPEG could be opened in any of the graphic related softwares. Likewise, the MP3 could be played in any of the music playing softwares. So basically, the difference between the two boils in the format. The text file format could be understood, is readable by human, but the binary format cannot be understood by us. Rather, it needs to be read and understood by the associated the softwares. So this is the brief introduction between the two. So today we'll be dealing with 5 programs, A, B, C, D, E. That makes, there is one more. So there are 6 programs through which we are going to learn how to handle the binary file. Let's go for the first program. The programs are maintained in the same notebook by the name of file handling. This is the beauty about the Jupyter. You could store the information just like how you do it in the notebook. Okay, without further delay, let's get started. Okay, let's pick up a very simple example. Writing a string to a binary file. From here on, we are not going to use the text file. Rather, we are going to use the binary file. So the first statement will be MSG equals welcome everyone. This is an example of a string, and then we'll open up the file object f out equals, and then open function, and then you have the path c colon. You can use the / as well. I just found that the / also works, but if you are keen on using the \, please watch out for the escape sequence. You need to suppress that either by using two double backslashes, or we need to use the prefix of r to convert the path into the raw string. Temp / let's say the name of the file is data.bin, and then you have the file mode. The file mode is W and then followed by B. So whenever you are working with binary file, the file mode will have a new addition of the letter B. So in the earlier lessons, we have file modes like R, W, A, W+, R+. So those belong to the category of text file. Henceforth, if you work on binary file, we need to add the character of B, which indicates that the operation on the file will be based on binary format. So if it's W+, if it's R+, whatever be it, but at the end you need to add the suffix of B. Let's go to the third statement. fout.write will try to write the string to the data.bin through fout. This is important. Encode. This function is very important. The value of MSG is welcome everyone. This welcome everyone is a plain text. This plain text should be converted to a binary format. The reason is we are not handling a text file, rather we are handling a binary file where the characters need to be stored in a binary format. So in a way, this encode function will convert the plain text of welcome everyone in a binary format. To be specific, the default encoding character system is UTF-8. I'll just write this for the sake of your knowledge. UTF-8. The default format for encoding is UTF-8, Unicode Transformation Format. ASCII is one character encoding system. Unicode is another one. In Unicode, again, you have UTF-8, UTF-16, UTF-32. So those, the character encoding system support much more number of characters. In fact, they are enough to represent the languages of the entire world. So let's not drag further. The encode function will convert the plain text into the Unicode, the format of which is UTF-8. Okay, and then there is another way to write a string to binary file using a prefix of b. fout.write. I'm showing you two examples via which you could write a string to a binary file. Let's say, welcome everyone to Python world. All right, so again, right in front of the first single quote, we need to add the prefix of b. This b represents byte. So again, byte is an object, byte is again a format. So this to Python world is converted to a data type by the name of byte. Let's not get confused too much. B stands for byte. Byte means the binary representation or binary format. So basically there are two ways via which you could convert the plain text into binary format. The first one is the function of encode, and the second one is adding prefix called b in front of the plain string or a plain text. And finally I close fout.close, and then let's run this. Okay, I hope there isn't any problem. Let's not go behind the scene and check the content, but even if we do so, basically when you try to open a text file and a binary file, the difference in the view is the text file, the moment you open it, you'll be able to read it just like how you read the plain text. But when you try to open and read the binary file, the plain characters, the English, the alphabets, the signs, the symbols, the digits, you will be able to see as they are. But the moment you try to display some additional characters which are beyond the scope of ASCII code, they will appear to be in a scrambled format. So which means the text editor is trying to show those binary numbers of 0 and 1 in their own capacities, as a result of which all they could do is the scrambled shapes and the scrambled characters. All right, so this is how you write a simple plain text to a binary file. We'll be using this a little later. Okay, let's go to program B. But before we go to program B, I would like to show you a difference between the two. Okay, so I think it's better to leave this for a while. Let's go to program B first. The program B says reading a string from binary file. So just a while back we have written welcome everyone to Python world in the file called data.bin. In the program B, we'll read the same content back. So again, first things first, we'll use fn open followed by c:/temp. The name of the file is data.bin. this time the file mode should be RB. Since I want to carry out the reading operation, it has to be R, but remember, since it's a binary format, we need to add B. And then we'll try to read the first string, message equal, or just to make the matter simple, we'll read both the lines. fn.read. So this is the function to read the entire content of the file, unless and until you specify the number of bytes in it. So I'll try to print msg and then followed by print msg.decode. Okay, so when I run this, you will see two kinds of output. Look at the first one, print msg. The value of msg is just welcome everyone to Python world. That was the original value of msg, but I get to see this B, I get to see the single quote, I get to see the second single quote as well. So this shows that the msg value is stored in a binary format, and when you try to display the same format, I get to see some unnecessary or additional characters like the single quote and the B. So if you want to read the binary file or the binary content, you need to always decode, just like how you encoded when you wrote the file. So just likewise, when you want to read the file, you need to decode first, and then you have to display the content of the file. So look at the second statement, print msg.decode. So this msg, the value of which is stored in a binary format, fn.read, you know, the fn points to the data, and in this the strings are stored in a binary format. So the binary format is read directly, and then it's assigned to a variable called msg. So when you print the msg value directly, you get to see the additional B, additional single quote. So this is not the right way to print or display the string which are stored in a binary format. It needs to be decoded first and then followed by the print statement. So technically it has to be like this. So this is the original value of msg, certainly not the one which starts with B, certainly not the one which has a pair of single quotes that was used in a program. So through these two programs, you need to know how to write string to a binary file, either using encode function or adding a prefix by the name of B. Remember that prefix B stands not for binary, rather it stands for byte. Byte is again a binary format using which the characters are stored in the binary file. So likewise, when you want to read the file, the moment you read it, they are in a binary format, but you're not supposed to display them as it is. You need to first decode the format back to human understandable format, and then followed by the print statement. So I hope you are pretty clear with the first two programs, how to write a string to a binary file and how to read a string from a binary file. I would like to add one additional program or a minor changes in the first program, which will give us a clear picture of the advantage of the binary file over text file. Let's say I would like to add Tibetan letter Ka or Ka, whatever, and then try to store it in the text file. Just a while back I said the text file is based on ASCII character encoding system, which has 7 bits. So 2 raised to 7 is 128, starting from 0 to 127. This particular range is used to represent the English language based characters. Let's say I'll try to add, or I'll try to write a Tibetan letter into an ordinary text file, and then we'll see whether the text file will run smoothly or not. But by our common sense, it should not work, because Tibetan letters, they have their own character representation apart from the ASCII encoding character system. So let's do this real quick. Let's say I get rid of this. Okay, I need this. So this time I'll use txt in place of bin, even though this will make not much of difference. And then the name of the file will be data1. All right, and then followed by, now this is nothing but example similar to the earlier video lessons. I don't need this encode. This is very familiar to you, hopefully. It's nothing but, you know, just one ordinary text file called data1, and then I'm trying to write welcome everyone. Okay, followed by fout.close, and then let's run this, and then we'll just check data1, it has welcome everyone. And let's say I'll try to add a Tibetan letter called Ka. I hope you can see. If I try to run this, that's when I get to see the error. So the crux of the matter is, clearly it shows that text file doesn't support any other characters which are not represented in the range of ASCII encoding character system. Say if I want to try this using binary, it should work. The default character encoding system used by the binary file format of encode function is the UTF-8. So we'll make some modification and ensure that this works in binary format. Let's say I'll change this to WB. Oops, sorry. I'll change this to WB, and then what else? MSG.encode. All right, and then I'll change this to or I'll leave it as .txt. It shouldn't matter much. That's it. I'm good to go. Let's say if I try to run this, it seems to be working. Even if I go back and check, this time I get to see this Tibetan letter of Ka. So through this short program, you know, you have a reason to feel good of the reason, you know, the why binary file holds advantage over the text file. Okay, so again, this is another angle to look at to differentiate between the text file and the binary file. Okay, so now let's go to the next program, program C, which is create binary file and store few records in it. So this will be the combination of first program and the second program. Now to start with, let's say I would like to open the file using with. This is important. With function or with keyword is again very useful. Let me first complete this. With open, open, and then C:/temp, and then I'll have another file by the name of names.bin. Since I want to write some names, I'll have the file mode of WB as F. Okay, so let me explain the significance of this with keyword. This with keyword will combine two related statement, two related operation. So what happens this with statement, with keyword, is it will first open the file called names.bin, and then the reference will be assigned to F. So this is the first related operation. The second related operation is the moment the block of code is executed, the moment the block of code is executed, the information which is in the buffer will be permanently written into the disk. So it's a combination of opening the file as well as closing the file. To keep it simple, it first opens the file, and the moment the enclosing, I've not shown you just as yet, but little later you will realize the enclosing block of code, once it gets over, even if it crashes in between, even if it completes, the moment it comes out of the enclosing block, the file handle of F will be closed, which will force write the information from the buffer to the file. Let's go further. Let's say ans equal y. Okay, I would like to keep the loop running while ans dot lower function will convert the character to lower alphabet. As long as this is equal to y, I want to keep the loop running. And then name is equal to input, enter a name, followed by, I'll be using the variable by the name of ln. So this is not 1, this is L. Often students get confused between the L and 1. Some font, they do not differentiate much between the appearance of L and 1, resulting in compilation error. So please watch out. ln equals len of name. I'll just go up and then I'll define a variable by the name of record size. This is important. Record size, I'll explain a little later. I'll keep it to 10, which means the individual name will occupy the total size of 10 bytes or 10 characters. In text file, you have the delimiter in the form of, they are line based, delimiter in the form of the new line character, which is a white space character. But in binary file, there is no delimiter character as such. So again, this is one important differentiation between the two. So it is all based on the fixed size of an individual data or individual line or whatever it is. Now let's say for this particular program, we'll keep the record size to 10. And then name is equal to name plus record size minus ln replication operator, and then followed by a space character. This is not multiplication operator. This symbol, when used with a character and an integer, it acts as replication operator, which means the space will be replicated this number of times. Whatever value that appears in this expression will replicate the space, and then finally will encode the name before it gets into the binary file. So we are all good to write the name into the file. So it has to be fout.write followed by name. Okay, and then we need to run a check whether the user wants to continue with the entry of names. So for this, ans equals input, do you want to add more names? Oops. Do you want to add more names? Okay, that's it, I guess. So we'll first run the program and then get on with the explanation. I hope I've made no mistakes as such, hopefully. Okay, there you go. Let's say the first name will be nay. Oops. Okay, so the problem is with fout.write name. Write to a closed file. Okay, Okay, I've made an obvious mistake. It cannot be F out, rather it has to be F. Simple, stupid mistake. Okay, let's run this. Let's run and then have nay first. Do you want to add more names? I enter Y and then Leo followed by Y. Finally, I have the Louis and then say no. Looks like the program has run correctly. Let's go back and check. I open the temp folder. When I open this, I see 3 names starting with Nay, Leo and Louis. Take a closer look. Soon after N-E-Y, I have some spaces. Likewise, after Leo, I have some spaces. Likewise, after Louis, again, I have some spaces. So let's go back and try to understand the program. It all starts with this, with open. So this will combine 2 operations, opening as well as closing right at the end. The question is, when will the file be closed? The moment the block of this code gets over, the moment the block of code which comes as a part of with, the moment it gets executed, the close function will execute. So you have 2 operations of open and close. Open and close combined using the keyword of with. The benefit is, even if the program crashes after entering Leo, the Nay and Leo would be copied permanently into the file, whereas the Louis, will not be copied because of the program crash. So in between, if there is a error which results in the crashing of program, the earlier names would have still been written permanently into the file. So that's a big advantage of F. All right. Generally, if I just start with open and close at the end, even if the program crashes after entering 2 names, all 3 names, will fail to be written into the buffer onto the disk, on the files on the disk. All right. So moving on, enter a name. I entered Nay. I'll start here. The value of ANS is Y. I convert small y to small y. The condition is true. I enter the first name of Nay. Nay gets into the name. The length of Nay is 3. The value of ln is 3. Name Nay, NEY plus record size is 10. 10 minus ln. The value of ln is 3. The number of characters in Nay is 3. So 10 minus 3 is 7. 7. So this particular space character is multiplied 7 times, and these 7 spaces will be concatenated with the NEY. So that makes NEY followed by 7 spaces. So this name will then be encoded. So prior to this, the value of name is in a plain text mode. So this will be converted in a binary format. Now this time name will have name but in a binary format, and finally it will be written, and then it prompts up this question, do you want to add more names? And I entered small y. ANS will be assigned with small y. Again the loop restarts. It doesn't go up there, it comes here, it checks the condition is true. Again it repeats for Leo, it repeats for Louis. Finally, when I entered N, the condition becomes false. That's when you come out of the loop. So this is how I write a program to create a binary file with some names. So in this program, you need to take note of this. With it combines 2 related operations of open and close in order to make the program much more efficient. Instead of this, if you want to use the customary method, get rid of this with, the F needs to come in the front, F equals open and all these parameters, but at the end we need to write F dot write. So this with seems to be combining open, this particular statement, with the last statement of close function.